Great. Now we have another concept that is domain of a function. In the beginning of this lesson, of this whole strands or substrands, we looked at relations, mapping, and functions. We made mention of domain of a relation. Okay, good. And what did we say domain of a relation is? So we are saying that domain of a relation talks about all possible values of what x axis. Okay, good. So the same thing here, we are talking about all possible values of the x axis. Okay, that is what the domain of a function. So here we are going to look at how, when you are asked in a question, you are asked to state the domain or state the largest possible domain of a given function. How are you going to do it? Now you know that for functions, we know we have various types of what functions. Okay, we know we have polynomial functions. We can have polynomial functions which can involve what quadratic functions, cubic functions, quartic functions, quintic, and all that. Okay, we can also talk about rational functions. We can also talk about radical functions, exponential functions, log functions, and all that. So we are going to look at situations where you may be asked to find the domain or state the domain of any of these functions. Okay, so in the first place, we are going to look at how we can state the domain of a polynomial function. So one, we are looking at what? Polynomial. Good. Now for polynomial functions, we shall treat it in our next lesson. Probably not the next, but we will treat it when the time comes. Okay, yes, it's a whole what strands that we shall be looking at. Okay, yes, as a main topic. So we shall look at that, but here we are going to find what the domain. So let's see some examples of polynomial functions. As I said, you can have quadratic polynomial, you can have cubic polynomial, linear polynomial, all that. Okay, so for a domain, let's say you are given the function. So let's say this is your function. You have your function as, let's say, y is given as the function. If the function is a polynomial, then when you're asked to state the domain, it's very simple. It means that every possible real number or all set of real numbers can be what? A domain. Now, in the actual sense, when we say domain, we are looking at the values of x that make that function what? Defined. Yes, they are the domain. So when we say domain, we are looking at numbers or elements, okay, that or the values of x that will make the function defined. Once it is defined, then we see that those values are what? The domain. Okay, so if we say find the domain of a polynomial function, it means that whenever you are given a polynomial function, every real number can what? Make that polynomial function what? Defined. So they become your domain. For that matter, you can say domain of, or you can say the domain, okay, is given as x is such that x belongs to all set of real numbers. Okay, all set of real numbers. You can write this, or you can say all set of real numbers. All set of real numbers. So when we say find the domain of a polynomial function, this is what you are going to write. So example, let's say you are asked to find the domain of this given function, which is equal to 2x squared minus x plus 1. Good. So this is what quadratic polynomial. Okay, and it is what a function. So once this you are given this polynomial function, then what do you do? How do you find the domain? We are saying that every real number you substitute, the function will be defined. So if every real number can make this function defined, then we say that the domain of this is what? X is such that x belongs to all set of real numbers. This is just your answer. So when we ask you to find domain, now if you are given another example, such as let's say j at x is equal to you have this half multiplying x squared minus 2. Now know that this is also what? A polynomial. It doesn't matter because of this fraction, even though we can say that this is a rational function, but because the denominator doesn't involve this, we can also call this what? Polynomial function. Okay, when we get to polynomial, you know what we mean by that, but looking at this example is also what? A polynomial, and the domain given also gives what? Domain. So you can write domain all set of real numbers. Okay, good. So either you write this or you write that. All of them you are right. So that is what? The domain of a polynomial function. Now let's look at the domain of a rational function. Good. So we are looking at the domain of a rational function. Now we are saying that a rational function is of this form: y is equal to f at x, which should be equal to maybe j at x divided by another function, so which is x each. So when two functions are dividing each other, then we say that it's a rational function. Okay, and for such domain, how do we find the domain? We consider the denominator. Okay, so in this case, the domain, you can say that domain is given as what? X is such that. So always you need to, if you are given rational function, you need to equate the denominator to 0 and solve for x. So the values that you get, you use it. It means that every element can make the function defined, except when this, okay, except when this shouldn't be 0. Have you gotten that? Good. So we can say that we have this here, x belongs to all set of real numbers. Then we have h at x, it shouldn't be equal to 0. Or you can say x is such that x belongs to all set of real numbers except h at x is equal to 0. Okay, good. So that is the domain of a rational function. So let's take one example on that and see how we can do that. Okay, all right. So let's find the domain, or let's take the domain of this. Looking at this, you see that one function, we are dividing one function by another function. So when you see that this is what? A rational function in the fraction form. So all that you do is just equate the denominator to 0 and solve for x. So we are going to have our 2x minus 1 should be equal to 0. Okay, So if I'm solving for x, then I will group like terms where I have 2x is equal to 1. Okay, so I can divide both sides by 2. Okay, great. So I have my 2 here. Then my x gives me what? Half. Okay, good. So once you have half, it means that every rational number can make the function what? Defined, except this half. Except the half that when you substitute half here, you are going to get the function undefined. So the values that you are looking for the values that will make the function undefined. So in all, you can conclude that your domain, my domain is such that, so we have x is such that x belongs to all set of real numbers except what? So we can say x shouldn't be equal to half, or you can say x is such that x belongs to all set of real numbers except x is equal to half. So you see how I've written the two domains. Either you write it like this. If you are bringing this, then don't bring the except. If you are not bringing this, then you bring the except. Okay, so that is how to find the domain of a rational function. Let's solve another example on a rational function. Okay, so let's look at the example 2. Good. So you see that we still have rational functions, and always we are saying that if you have rational functions, then equate the denominator to 0 and solve for x. So the values that you get, it means that it is that value that will make the function undefined. Okay, all right. So if that is the case, then I will have my x squared minus 9 is equal to 0. Now you know that we can solve this by difference of 2 squares, or we can even send 9 here and then take square root of both sides, how we solve it. But I'm going to use difference of 2 squares. So here I will have x squared. You know that I can write this also as this. Have you gotten that? Then if that's the case, then I will have x minus 3 difference of 2 squares, so I have x plus 3, which is equal to 0. So it means that I will have x minus 3 is equal to 0, or x plus 3 is equal to 0, where x is equal to 3 or x is equal to negative 3. So this one, it means that every element or every rational number, every real number can make the function undefined except 3 and negative 3. So you can conclude that your domain, so for your domain, you can see that domain is given as x is such that x belongs to all set of real numbers. X shouldn't be equal to 3, or x shouldn't be equal to what? Negative 3. Have you gotten that? Or x is such that x belonging to all set of real numbers except x is equal to 3 or x is equal to negative 3. Great. So that is how to find the domain of a polynomial function and a rational function. Now we will end here and continue next time in our next video. In our next video, we are also going to look at how to find the domain of a radical function when you are given functions in the square root and a fraction form and a square root. We are going to look at all of that in our next video. So see you in our next videos. Bye bye.